All right. We're just getting started. Got to post this tweet. Get rolling. Hello. Hey, Nixia. First, welcome back. Welcome back. Oh, I don't want that. I want here. Come on. All right. Gotta just share this. You're faster than Vercel. They did all right in the HTTP bake-off that we set up last week. There is nothing wrong with that. Oh man, it's all X now. I can't believe it's all X now. All right. Let's get rolling. Hello, Nixie, how you doing? Welcome back. Happy Saturday. Hope you're doing well. We got to do what Milky does and like our own tweets. Boom. Yo, Sir Brad, thanks for the sub, man. Appreciate it. That's huge. 4th sub I've ever gotten. Much appreciated. Welcome to chat. Thanks for hanging out. All right, let's get going. Okay, so here are the results from last week. Here's what we set up. I want to talk about the methodology really quick. These are the flat results that I just tweeted. They are in order from fastest to slowest. Hono.js barely counts as a web server in my opinion, but I think that's a good comparison point because it doesn't do as much, and that's kind of the thing we're trying to do, right? Oh my god, who just gifted 6? Anonymous just gifted 6? What? No one's ever gifted anything before. I've never seen this. Yo, thank you so much, whoever just gifted 6 subs. That is crazy. I've never seen. I'm seeing this hype train notification on my chat. I don't know what that is. I've never seen that. But that was my goal. That's so crazy. Thank you so much, Anonymous, for the 6 gifted subs. Thank you. Wow, that made my day. We've been streaming for 3 minutes. Thank you so much. All right, so let's dive in because I'm excited to talk about this, and this is a long time coming. Oh, thanks so much, Sir Brad. Yeah, I appreciate it because you never use Twitch. Okay, well, I promise I have YouTube chat up today. So I've got on my laptop monitor, I've got YouTube chat up. But I really do appreciate you hanging out in chat. And wow, thanks again for the gifted subs, whoever did that. Okay, so what are we looking at? We're looking at the results from the last week of testing. There's a lot more data than this. This rolls up the points, and it's rolling it up with a trimmed mean P99. And that is important. That is something we didn't do last time, but we need to do it this time because we've always been comparing against Lambda here. And when we do that, you can see Lambda itself pretty steady overall for the week, right? Not bad, pretty flat, but still some spikes. But watch when we turn off that trimmed mean for Lambda. So if you just go to regular P99, there's this massive spike that comes out of nowhere here. So, and that was like actually the highest point for the whole week was this AWS latency. And we can look at the data. I don't mean to hide this at all. What a trimmed mean will give you. And I talked with my friend at work who's a statistician from MIT, flex that by the way. And he had mentioned that on distributed systems, especially when we're dealing with tail latency problems, it can be very helpful to look at a trimmed mean just to hide any of these crazy outliers. So you can see like it basically throws away the top. In my case, I did 1%. So like the furthest outlier, we basically are looking at the P98 would be the other way you could say this, right? So we throw out like this point is going to disappear, that point's going to disappear. It also helps, I think Vercel had a couple of ones, not too bad, but that big point up to 800 is crazy. Hey, Scala Guy, welcome to chat. Why not Cloudflare? Great question. Cloudflare is great. First off, huge fans. Shareholder, by the way. Long Cloudflare. Great product, great team. Love talking with those people. Some of the sharpest systems engineers I've ever had the pleasure of hanging out with. But Cloudflare workers are run on worker D, and they are similar to V8 isolates and like little WASM Python runtime. So it's not, you can't bring the same application in. Nixie, yeah, got to shill and pay for that stroller. Exactly. Cloudflare, get at me. No, I was just disclosing my conflict of interest with Cloudflare, that I'm also a stockholder. Oh, hey, Bronify, welcome to chat. Thanks for hanging out. It looks like you got one of the gifted subs from Anonymous. So why not Cloudflare is it isn't just Node.js. You can't just drop a Node.js application in Cloudflare. And one of the reasons I love it and I shill so hard for the Lambda web adapter, even though slowest, by the way, objectively true, it was the slowest. But the Lambda web adapter lets you do something really exciting, which is you can take any web application you have running anywhere today and plop it into Lambda and deploy it in 10 seconds, and it's up. So yes, is it a little slower? Yes, it is. It has to conform to actual pretty strict HTTP semantics, which Hono doesn't do, Vercel doesn't do, and that's fine. They don't have to, right? Like all of our performance advantages, everything we're trying to eke out of these systems comes from us doing less. And that's great. That's part of the job. That's part of the business. That's why we do it. But if you want to take an existing, like say you have a Java Spring Boot application and you use it once a year and you just don't want to patch the OS every time, you just want to throw it into Lambda, you can drop it into Lambda with a Lambda web adapter and it will just run, especially if you don't care as much about the cold start latency. Maybe you're going to pay for provision concurrency, and that's fine, right? You can pay for that straight out of the box. It's always warm, no problem. This disappears entirely. Yeah, I got to shill hard for that stroller. So anyway, that's why the Lambda web adapter is so great, even though I think it's on the higher end here. Both serverless HTTP and the Lambda web adapter are running Express.js applications. They're all identical. They have to conform to that same response. And as usual, they are all open source. And we're committed to open source here. We're committed to building these benchmarks and these tests in public. Anybody can stand these up. I've gotten feedback from lots of different people who have sent me notes with suggestions and ideas. One idea that actually the Vercel team got back to me. Oh, wow, we got a hype train success. Thanks. Vercel mentioned that we should add environment variables because they do come with about a 20 millisecond cold start penalty in end-to-end latency. And that is a non-negligible amount here. So that's what we're looking at, right? We want to make sure we're tracking that. So I added environment variables for everybody across the board, which I thought was totally fair. Wait, did I hide them? I don't want to hide them. Show me all of them again. What? How did I hide it on the graph? Lambda web adapter, what is NPM package? Lambda web adapter is actually a Rust project. Why aren't these showing up? It's a Rust project, and I can show it off here in a second. Nacho, welcome. Thanks for hanging out. I'm great. How are you, man? Good seeing you. Happy Saturday. Oh, NPM is a package manager. Yeah, exactly. It isn't a node package, though. Lambda web adapter. We'll plug this in chat real quick. Great project. I talk about this a lot on stream. Good. Glad to hear you're doing well, Nacho. Yo, Joich, welcome back. Welcome back. Thanks for hanging out. Great project. If you are new to Lambda and you already have a Node.js application running on your laptop and you want to just put it into Lambda, this is the fastest way to start. And I would recommend just starting with this. It's okay. What it's going to do is translate your, if people mentioned stream because I mentioned Cloudflare mentioned, what it's going to do is translate all these events coming from an HTTP endpoint into a HTTP request on your application instead of Lambda's event model. So you get that just free out of the box. It's this little Lambda extension. It's Rust. It's pretty low overhead, but you can see it does have some cost. It's not free. Why did I break this line? Is it here? Oh yeah, here. I want all of these. Boom. Why is, I don't know. Oh, there we go. Double click. Yeah, so it's not free. You pay a little bit for it. There you go. You do, it is the highest overhead of the options we have today that we can talk about. And it does have some outliers. And that's what I was saying is like, there's like this really bad outlier. Yes, Bronify, you can use it with CDK. Works just fine with the CDK. This abstraction does exist for most languages, George. Yeah, so serverless HTTP is the canonical Node.js example. That's the example which lets you use any like Koa, Express, any of those little tiny web servers, whatever you got, and you can drop it in to Lambda. So, yo, thanks for the follow. Glitch Game Dev, welcome to the stream. Thanks for hanging out. We're talking about performance. Okay. Sweet. Okay, so why trimmed mean? Like I said, we've got some of the, like, Lambda is this massively distributed system. No, it doesn't have to be Docker at all. No, it doesn't have to be Docker at all. I'm actually not even using Docker. Would I take this path or jump straight directly to containers? It depends, Nacho. If my application is already like containerized, especially if I'm heavily using it in the build process for my application, like say I have a Node app that needs containers because I am doing a bunch of packaging, bundling, maybe I'm compiling something for my target. You know, you've got like a C extension or, you know, one of the like the C++ kind of extensions to V8, then yeah, like the container is going to be just much easier to ship. If you just got a plain JavaScript application with plain JavaScript dependencies, it may be easier to just put it in a zip file. But honestly, I still 90% of the work when I advise like clients or I do work on my own is I just put it in the Lambda web adapter, and then I use provision concurrency, and I use auto scaling groups, and then you save a lot of money because provision concurrency is actually cheaper. Like the billing is cheaper. So once I have enough users, then that's a no-brainer. I feel you are DevOps qualified. I hope so. They made me an AWS hero, so hopefully. Trimmed mean. Okay, so all massive distributed systems have a huge amount of noise. Remember that if we haven't drawn this, we should draw it out because some folks are new in chat. Maybe you haven't worked with Lambda. Inside of AWS, in this case, this is one region, US East 1, there are 3 AZs. Actually, I think there might be 5 in US East 1, but it doesn't matter. These are each physically separated buildings with separate power supplies, and they're on separate floodplains. And the idea is if this building burns to the ground or floods, and you have a distributed system that has implemented a correct consensus protocol, something like Paxos or Raft, it will hand over control to another AZ, and you won't have any interruption to your customers. Lambda is deployed like that. So in any of these, yes, George, separate floodplains. AWS has done incredible blogs about and talks. You got it, James Hamilton. This is the guy. We got to talk about James Hamilton, dude. First off, I got a photo of him. Is that why there are no DCs in the Netherlands? I think they have one actually. Yo, Amain007, welcome to chat. Thanks for the follow. This guy's a legend. He's super cool. I love chatting with him. He's like extremely eccentric. He hangs out. He lives on a sailboat and sails from Hawaii to Seattle to work for Amazon and then back and just hangs out. He built out a ton of Amazon's data centers. So check this guy out. This is a great talk.
Working with at the time.
He's super kind. I love talking with him. He's given me a ton of time and answered a bunch of questions for me in the past. He's great. So he built out a lot of these data centers. But yeah, they talk about why they're on different floodplains, why they have different energy sources or energy systems, like supplies. They also have backups, of course. Closest one is Frankfurt or Paris. Yeah, I was gonna say, I don't know if they have one. I think it would be, yeah, Frankfurt would probably be closest than Paris. Let's say I have a Signals WebRTC server. How would that fit in this architecture with Lambos or Lambdas? I mean, first off, if you got Lambos, you should just be rolling in that no matter what. WebRTC is a little trickier in Lambda because I think, hold on, let me Google this, make sure I'm talking about the right thing. This is the real-time chat protocol, right? Yeah. There is a WebSocket implementation for Lambda, but it's not sticky, so you have to maintain state yourself. I don't really recommend Lambda for real-time stuff. Yeah, I was gonna say, I thought they announced one in Amsterdam. Maybe it floats? Who knows? So what happens here is that Lambda, they have a different deployment of fleets of Lambda server in each AZ, and you can get any one of the 3. So that's one of the reasons our benchmark will test against all of these different, oopsies. This is why we're using this benchmark to test over time, because we may get a different zone, like the Lambda function for Vercel may be in the same AZ, and we test that once, so we get a very fast point. But at the same time, these are fleets of computers. There are 2 services behind Lambda. There's the placement service and the worker service. Those could be busy, those could be, down, they could be some network latency. So we just want to test for a long time and get a bunch of points. And that's what we did. We can calculate the number of points too. And then one of the advantages of Lambda is just that you get this high availability straight out of the box. So you don't have to worry about, you don't have to worry about the distributed thing right away. Cloudflare call and durable objects for WebRTC. Ooh, that's great. I haven't used it, Nacho. That's sick. What are you using WebRTC for? Oh, let me guess, Scala Guy. You're building something for Twitch chat. Pretty cool. Amsterdam is 2 meters below sea level. That is true. Oh, 11 Tmux panes. That is way too many. Okay. Oh, right here. Okay, here's the project. First off, is this in a? Oh, I don't think I've done it. Okay, so we need to create a repo. The first thing we got to do is keep this Rust project in the repo. What should we call this thing? This is the Rust curler counter. Okay. Curler counter. I don't think I like the word Rust in there. MV Rust. Not MB, MV. Let's call it that. Cool. Oh, NeoVim guy. Yes, I've used Vim for 15 years. So maybe longer. When did I? Oh my God. What is it? It's 2024. When did I start using Vim? Probably 2011. 13 years. So, okay, not that long. 13 years. Okay, curler counter, public, always public, license. Okay, we have one additional clause we have to make to our license, chat. Let's just first off, let's add this. Did anyone check? Did anyone look at any of my other repos from this? Nacho, did you look at any of the repos we were working on stream? Maybe not. Okay, we have some work to do here. This is good. We're gonna write some Rust today. Yo, thanks for the follow, Ben Winnin. Ben Winnin, hope you're staying winning. Thanks for the follow. We gotta add a file. Add file. Choose a license template. MIT. Review and submit. We'll just go ahead and add this to the MIT license. There we go. Perfect. Your license is ready. Wow, that's so great. All right. No. Perfect. Okay, folks. You heard it here first. 100% Rust. Oh, wow. That looks great. You got to see it. Now you can sue 50% of viewers. MIT V2. Yeah, you know, I live not too far from MIT. I'll have to walk over there and see if they'll accept my contribution. I noticed, so if you modify the license, it doesn't show up here. Oh, it does now. Yeah, there we go. Okay. Mine didn't before. So there you go. MIT license with a little amendment. Amended MIT 2. Hamo Dazx. Welcome to the chat. Thanks for hanging out. Okay, curler counter. Sorry, I should have given you guys a light mode warning. I forget how to switch out. On my work browser, I have a different setup. Where do it? Is it really in the settings? I can't just hit a button here. I know. I need to chat. I need to warn you folks before I blind you all. Oh, it's under appearance. There we go. Okay. Sorry, chat. Is that better? Everyone happy? I missed a follow. I forgot who just followed me. Let me go back. Hold on. I want to say thanks. Dyrene, thanks for the follow. Thanks for hanging out. Okay. Chat. Oh, wow. Peniela07. Blind out too late. Hey, welcome to chat. Hamodaz XX. Thank you for swinging by, for the follow and saying hello. So I'm sure some of you know this. Maybe you've seen oh, thanks for the follow, Scala Guy. We're building a Rust project. we're building a little metric creator in Rust, and it creates points for in CloudWatch. I don't know how this guy does all this content. Holy smokes. Maybe you saw this. Dax did this interview
over the weekend. I don't know how many people
Prime.
saw, but there was a bunch of tweets going back and forth between pretty much Dax versus Vercel is what it looked like.
It was
whereas
all
AJ
about this
from
work.
Datadog was just providing numbers, and everybody else
What a line. Hold on. I should have been talking.
versus Vercel is what it looked like. Whereas AJ from Datadog was just providing numbers, and everybody else was providing an insightful amount of misinformation. So I thought
Oh, we talking about the Milky too? Wow. Yeah, so this went out, 95,000 views. My stuff just blew up. Twitch blew up. I think I had like 200 followers at the end of the stream last week, and now I have almost 393. Appreciate y'all, every one of you. So this was very kind. Obviously, Dax and Prime had a lot to say. I think they were, as you can tell from the introduction, they were more interested in the discussion between, Vercel and people on the internet on Twitter, and maybe less about, all the data. This stream has been really focused on the data, although I must admit, once I saw this video, or that the stream went live, because I was in chat for a bit, I hadn't seen a lot of these tweets he was talking about. I hadn't followed it because I'm not tagged in all of them, right? Like it was like a quote tweet or like a photo of my tweet or something. Or like, a quote tweet of Dax's tweet or some other stuff. So that was crazy. I couldn't believe how much that blew up. But there are a lot more of you here, so I appreciate that. Hernan Ars, thanks for the follow. Welcome to chat. Thanks for hanging out. My Twitter stuff went wild too. Like I don't think I've ever had this much. We gotta look at the analytics here. How does that work? It's under premium, right? What is it this? Oh yeah. Oh, Sura, really? There's a material icons for GitHub Chrome extension that gives you file icons like in VS Code while browsing repos. I know you can hit the dot and you can bring up like the code editor, and I've used this a little bit. It's not my favorite though, because I think it's a little trickier to find the history. Yo, Pyrrhic GT, thanks for the follow. Scala Guy, after staff engineer, next level is principal. At Datadog, we do senior staff, and then principal. But I think we just have our second ever principal engineer. And principal level at Datadog is equivalent to distinguished engineer. At Amazon, it's VP level. And that's the top. Okay, so yeah, this was nuts. I want to show this. This went wild. Like 2 million impressions. I had in the last month almost 1,200 new followers on Twitter. I've never had anything like that in my life. So thanks, Prime. Much appreciated. And thanks for all the kind words. So, it just replaces the generic file icon with the proper one for the file type. Oh, that's fine, but I'm just reading code, man. Yeah, exactly. 523% on the impressions. And like everything this is like nuking. Just wild stuff. Oh, Dax already retweeted this. Okay. Well, I want to get back to this. Let's start building. So yeah, this was nuts. Thank you all. And again, yeah, I've got almost now, thanks with Pyrrhic's follow, I'm up to 394 followers on this website. And thanks to an anonymous gifter, got up to 10 subs right now, which is wild. Okay, curler counter. You know what, Sir Brad, we don't need a file browser. We have NeoVim. It's all one file anyway. So if you're new to the stream, here's how this is working. All of these Lambda functions are running, or Vercel functions. They're running out, and they return a payload that looks a little like this. So we're looking at kind of two factors. For our curiosity, we like to look at when the Lambda function handler initialized, and then when the handler ran. So this difference helps us understand the difference between how long it takes to load the code. We're not doing anything with it right now. We're actually just throwing them away. That's why Clippy is complaining that they're unused. There are two things we care about: process uptime and cold start result. Vercel does something great that I think Lambda should do, which is every time you deploy your Vercel function, whenever you build a new version of your Vercel function, they warm up one instance for you. They go out and pre-warm it with a request. It costs them nothing, right? It's like a fraction of a penny, right? Whatever it is, 1,000th of a cent or something crazy. And the whole benefit is you get a nice developer experience when you go to hit that endpoint. you get to like you make the request and it's not a nasty cold start. And I think when I talked to some folks about it, they said, yeah, I mean, like, it makes sense. Like early on when Guillermo was trying to raise money for Vercel, I'm sure it was not great to have a new deployment and then see like a cold start immediately. That probably sucks. So they warmed them up. AWS should just do that for you. But when they do that, that means that we don't always know what a true cold start is, right? Because we might get the true response back, even though it was like a deployment and it warmed up. So let me take a look at the process uptime. And right now I'm just saying, is it longer than, what do I care about? If the process has been up longer than a second, we know they warmed it up, right? Because the request, all of these requests are less than a second. Hey, probably TV, welcome to the chat. Thanks for hanging out. So we just toss that point. What we could also do is just say like, is the round trip time less than the time, the process has been up? Because then again, if the request came there and back in less time than it took for the process to be awake, the process was running before our request, so it wasn't really a cold start. Probably TV, thanks for the chat, thanks for the follow, welcome, thanks for hanging out. We're talking about Lambda performance. How do you get to staff level? It's almost like a gut. No, it's nothing. No, that's not what it is. We should talk about career stuff. I haven't done that on chat. I've talked with like Milky a lot about it, one-on-one, but not really. First, I've been writing software professionally for 12 years. So that like experience is a part of that for sure. Oh, one sec. I just got to text my dog walking buddy. All right. Yeah. Hey, probably TV. We're talking Lambda performance. We just went over the results from last week, the metrics from our end-to-end latency test. Yes, these numbers are higher than you would expect. That's intentional and normal. We're doing a round trip latency test, so it includes network chatter and client chatter. But the relative performance is what's so interesting here, right? Because when we know that this is just like a plain Lambda function, right? So we know this point is the minimum. Then we can do a bunch of interesting stuff with the rest of these, right? Because we know that now we're comparing, the benchmark, or I'm sorry, like the comparison point against the rest of them. So, and then we were talking about why trimmed mean P99. So let's do that. So basically it throws away these giant spikes, which are almost certainly either some weird network hiccup or latency in Lambda, which is uncontrolled. It's not really a reflection of the performance of the system. So trim mean throws out that top 1%. You can go ahead and take a look. Probably pretty alien concept. I just started Software Career a year ago. We could chat about Software Career for a little bit. That's great. Welcome to the industry. I don't think it's nearly as bad as everybody says. I do think it's hard to find like a 6-figure remote job right now if you're new. There was a weird time in the pandemic where that was maybe the case. And then, people were doing stuff like working 2 or 3 jobs at once, and none of that was sustainable. I'm not really worried about AI replacing anything. I'm using AI. We'll use Copilot later, and it's helpful, but not everything. But welcome. It's a long, rewarding career. My best advice to anybody in this chat or anybody who is talking about their career or interested in how to level up their career, go one level deeper. Wherever you're at, whatever your understanding is right now, go one level deeper. If you're, brand new and maybe you started on a full stack route, learn about maybe how the browser works a little bit, or learn about more how the backend works a little bit, and just kind of keep taking it, another notch, because all of those learnings you take are another step, probably more than most people have done, and they are an advantage for you for your career, right? It's like another amount of learning that you've got. How do you pass the interview to staff level? You just go to leak code. No, I'm horrible at leak code. I actually almost didn't get my job at Datadog because I failed the leak code, and then they sent me like a take-home problem that I was able to just kind of put my headphones on and work on for a day or two, and then they accepted me. And then I got promoted to staff because I basically was one of a few people that built out our entire business on top of serverless for AWS, and that is worth a lot of money. So then there's some technical advantages too. Related to Lambdas, have you ever tried FN Project IO? Monster back, welcome to chat. Thanks for hanging out. Kojak, thanks for the sub. So that's why you love so much serverless. I've just been in it a while. So this shirt, I used to work at this company. I don't know if you've heard of the serverless framework. This is the most popular way to build and deploy Lambda applications, I think, still right now, even over the CDK. And I mean, it's got some ridiculous 46,000 stars. So I worked on this for a while. I started there in 2018. And that's kind of, before that, I was still working on serverless. I started working on serverless in like 2016, 2017. Hard to Datadog have to use Signos for budget. I understand, Monster. Check out our serverless stuff, though. Our serverless stuff is priced pretty competitively. Yo, Amur, welcome back to chat. FN Project IO, I've never heard of this. This is cool. Container native, serverless platform. Wow. No, I've never heard of this. Oh, straight to the repo. Who are our authors? Do I know these people? Oh, a bunch of Oracle folks. Interesting. Firebase and Superbase. I love Superbase on Twitter. I've never used their product. Shout out Superbase. Firebase, I've heard nothing but good things, although I know that it's tricky to, there's not really another alternative, so you're sort of stuck with it. Think it's still great, though. Like a good product. A lot of people watching YouTube today. Hi, YouTube, if you're there. Hello. I'm keeping the chat open, but no one said anything yet. That's totally fine. Here, we'll pop out chat. Okay. FN project runs on your own K8s. No admin required. No admin required with K8s. Psh, kidding. Kojak, thanks for the sub, man. I really appreciate that. That is awesome. I just got my first ever gifted subs in the channel. That felt awesome. I've never done that. Probably TV. Are you a full stack developer? Did you specialize in particular? I'm a backend developer. Been a backend developer my whole career. I got my start writing Perl in a medical device, and then I was a systems engineer there, actually, working on installing their medical device software on top of Red Hat Enterprise Linux, and then I built this like in-place upgrader. Yeah, Scala, I know I'm dating myself here. All of that was written in Perl. And then from there, I worked at a Ruby on Rails startup as a backend engineer, and then we built out a couple of distributed systems. One that I at the end of my career there, I lovingly called Commander Q after the character from Star Trek. Yeah, and then went to Serverless Framework and built out their backend system for telemetry, and then Datadog work on Datadog. We own our own services, so I run a couple of K8 services as well as do all the library and open source work. Yes, you should use a data API, Amor. No, never did COBOL. never had to do COBOL. All right, let's make sure this project still builds. Happy to chat all the way through it. So this is the project we're going to go deploy on my Raspberry Pi. We have this hash map of function URLs. We have to build this from environment variables, though, which will be a little trickier. Not that much tricky. So we can take a look here. Okay. Cargo build. Is that may be a little small for folks? We'll make it a little bigger. Chat, feel free to shout out if it's too small or too big. Everyone can just see, okay, everything but the edge. All right, this is great. And I think we got the point. All good, thanks, Ben. Learning Rust in my current start. Rust is great. I write Rust all week right now. It is a pretty big learning curve. However, I think it's pretty manageable, actually. We have a couple of new career engineers that are picking it up really quickly. People that like skipped Go. Yeah, coming from a JavaScript. So like that would probably be my like starting point. But I never did React. I never did any. I did a little Angular, and I've got maybe 10 front-end PRs at Datadog in my life. If you use any of our Lambda stuff, then you've probably touched some of my React, but otherwise probably not. Thanks, Monster. Yeah, we have a mind-boggling scale. I can't say a lot of the numbers. I can tell you we process like on the scale of trillions of points a day, like trillions of data points or data requests per day. It's nuts. It's a stupidly huge backend. Massive. Like we don't. Here's what I would say. We don't hire backend engineers really. We have our front-end engineers build all of our own APIs as well, and then we have like distributed systems engineers. that's the thing. So like if you come on board for like a full stack role, you're gonna write Go and you're gonna write React. Rust is great. Oh, yo, I had the coolest thing. My friend My friend at work left this on my desk. This is Rust for Rustations by the compiler author of Rust, John, how do I say his name? Jingset? I can't pronounce it, but it's book number 10 and it's signed. Pretty cool, huh? Guy works in Boston and yeah, gave me this book. I also love Go. I love Go. I don't want to, yeah, George, I was stoked. This is awesome. Been paging through it already. Go's great. I don't go like, it's a fantastic language. It is really well developed. It is very easy to build good, well-performing software in Go out of the bat. There are just like two things that really pain me about Go. Where am I based? Oh, hey, yeah, I'm in Boston. We just moved here. I was in Minneapolis for a while. The Go's error handling is one thing that's not my favorite, but also the biggest thing is it's so easy to create memory erasers in Go. I don't know any FPP languages. No, I should have known this question was going to come from you, Scala guy. Hey, Sir Bradley, does Datadog capture traces when a Lambda function times out? Well, I'll show you. Oh, I can't. That's right. I don't want to. Here, we can. I don't want to SSO. Boom, boom, boom. So, yeah, we do now, and we do. It depends on the language, but we do support timeout traces now. Where is it? So this will, when the Lambda function times out, we can now get spans. And yeah, your boy did this. It's super easy to create race conditions in Go. You love what Prime highlighted about Go. Like every Golang developer writes somehow similar code in contrast to C# and Java. Yeah, I mean, I think that's sort of true, but it's also pretty, like, it's idiomatic. That's why there's like because Go had an army of Google developers building the language out. There's just really mature libraries for it. But it is easy to do. It's easy to create data races in Go. You can literally pass two different threads a slice of the same string, and boom, you have a data race instantly. And that's I think the biggest challenge is that then gets bigger. You can import C code. So you have what's called a FFI. So you can do a foreign function interface, and then you can call in. I think this is a good blog post, right? Daniel Sedlak. I feel like the name's familiar. So basically, there's like, instead of a C, you take a C header, and then yeah, exactly, just like Node. Yeah, correct. Bronify two Go routines concurrently, not just the same slice, but literally any, like if you have a struct and you don't lock it, you don't have like a mutex around it, you can easily create a data race. It's just an accident, man. It just like strings are, slices, right? So you like pass around a string and one person mutates it and you just end up with this problem. I mean, any nil pointer error is like a data race for the most part. So big fan of Rust. And I also, to be honest with you, if you know Go, like, don't be scared of Rust. You can write this. It's not that, like, I'm not using lifetimes here. The implicit lifetimes in the borrow check are fine. They're doing just fine, right? It's okay. It's not that different. Okay, so this worked. Oh, I want to make sure, actually, what do we call the metric again? It's namespace AJ local metrics. Okay. So let's go back to CloudWatch. Probably TV, the references concept. In Rust or in Go? You can just, okay, so think about references as pointers. Yeah. So Rust also has like this concept of pointers, but you pass it via the ampersand, similar to what you would do for a pointer reference. Just think, when you think pointer reference, think reference when you think pointer, and then you got it. So like I create this config, and what owns this config is this closure input metrics. And by closure, I mean everything here. So I'm going to fold it. So no. So everything in this closure is owned by put metrics, and this function doesn't return anything, and it takes a vector entirely. It owns it. So everything in here is owned by the put metrics function. So when I create this config, so I create this variable, I allocate space for this, it's going to go on the stack. And then I pass it into this client, and I borrow it That's what this means. So now I've borrowed this config. Now if I try to use the config again, like config dot whatever, something, I think it should complain. Oh no, maybe it won't, because this passes it back. But if you don't borrow it, it can complain. So it says consider borrowing. And all it's saying is that you have to lend the scope of it to this method. But I'm guessing that this either doesn't use it or it just reads it. Okay, yeah. So it doesn't take ownership over anything. So once this method call is done, you can reuse the config variable. We'll talk about it in a bit, because I'm sure we'll hit something with the borrow checker and we can make a better example. But it's literally just all this is it's a pointer to a spot in memory on the stack. And yeah, George, that's a good example. Like if we wanted to return something here, if we wanted to return something and have it like, return like a result, we can, well, okay, that's just going to want to return an error. But if I want to return a result or something, like return some actual data, then now I have this like reference I have to deal with. I guess that wasn't a good explanation. Let me find a piece of code where I use it, because I just wrote a bunch of this stuff this weekend or this week. What was I working on? Datadog, Lambda extension. All this is open source, y'all. Okay. So here's a great example. So we have this config. Let's look at bottle cap. So we have this config. Maybe the diff isn't going to be helpful. Let's just look at main. So we create this configuration and we create it from, we're using a library, but then we have it in memory. We have this struct. This is bin bottle cap main. Okay, so we have this struct and we need to pass it around. So we have, let's go down. This is a Lambda extension. So we create this configuration right here, let config equal match. And so this returns some configuration. Now we have a reference to config, but I need to pass it to 3 different people. And in Rust, you can't do that. The whole idea of the borrow checker is that one and only one thing can own it. So what do? We're wrapping it in this call to arc. Arc stands for atomic reference counter. In any garbage collected language you're used to, this is happening for you magically behind the scenes. In Go, this is all implied. So just delete the idea of arc in your head and you're writing Go, right? Which all this is saying is config is stored on the heap, which means multiple functions can share access to it. And now I have a reference to it. Atomic is an elixir. Yes, and more specifically, Scala guy, atomic as in CPU, like multi-core atomics, which we can talk about in a second. Let's bring that up in a new tab and we'll talk about it. Atomics means something very specific and very technical, so it's important that we address it correctly with the right terms. We don't say that to be jargony. We say that because we want to be precise, because we're talking about precise concepts. But let me get back to this. We create this configuration. This is allocated onto the heap. This config is exactly what you'd think, right? It's like, is this setting on, true? Is this setting off, false? All that stuff. So we have this reference, but now I need to share it. So I wrap it in this construct called an arc. And what this does is it lets me call this. Let me find where I'm using it. Right here. So now any place I need to make a copy of it, instead of copying all the memory, and this config could be like, I mean, it's got a few strings and it's got a couple Booleans. So let's say it's, I don't know. Let's say it's like a kilobyte, right? Like 1 KB. Instead of copying that kilobyte over and over and over again, we just create a reference to it. And then the atomic reference counter just increments the counter for every one we hand out. And now these are 1 byte pointers into memory. So when you look at Rust arc, I think they have a picture of it. Do they? No. Is it by example? No, there's a photo of this. I've seen it. Everyone uses the same layout for their Rust books. I don't know if I could find it. Ask ChatGPT. Yeah, okay, here's what I'm looking for. Okay. So when you have a reference counter, you can, on the heap, you have this reference to the actual string. In this case, it's 42. And then answer to life, these are all variables. Answer to life, the universe and everything. Every time you call arc clone, it increments this value on the heap, and it gives you that pointer to the space in memory. So it's just like a level of indirection, right? So you just think like you've got, 3 variables that all call arc config, that all call arc clone config. That is a 1 byte width pointer to another spot in memory on the heap that says, oh, here's where this actually lives. And then that lets you have multiple references. And then when that goes away, when the scope ends for this, the atomic reference counter is decremented. And that is garbage collection. That's what your reference counting garbage collection is doing. Yeah, probably TV, there's no garbage collector in Rust. So you have to allocate your own space, and you also have to free it. And when the freeing it is anyone can malloc. Yeah, exactly. Squidward, welcome to chat. Thanks for chiming in, man. And D Mulroy, I recognize you from Twitch. Is that Dylan Mulroy? Or from Twitter, I mean. Welcome anyway. Thanks for the follow. Yeah, exactly. So you need to keep count because you need it for knowing when you can garbage collect this actual value, or not garbage collect, but like delete it or free it. And then you need it so that you can also pass out multiple copies, because in Rust only one function can own a chunk of memory. Hey, it is you. Welcome to chat, man. I knew I recognized you. Thanks for the follow. Fellow Rust enjoyer. Yeah, so it is also part of thread safety. And then we're not using any threads here, but it doesn't matter. I mean, we are in the example I was showing you here. These will all run in different threads. So they need to be atomic reference counters. Okay, atomics. Let's talk, no, not atomic software. So I tweeted this blog post that I really want to show you people. You would love this. So atomicity, yeah, it does come from database transactions is the term, but an atomic, atomics in software refer to how memory is accessed or shared in multi-core CPUs. Yeah, you got it. Probably TV, no problem. So if you think about a process, say you have 4 cores on your CPU. At any point, they can run the kernel, in this case a Linux kernel, or on my Mac system a BSD kernel, can run or execute or resume a processor thread at any point, and that is done by the Linux scheduler. And what the atomics library or atomic semantics lets you do is decide how memory references or how the CPU executes your instructions related to references in memory, meaning that the CPU can reorder your instructions so your code can run differently on different lines if the compiler and the instruction pipeliner on your CPU, well, compiler ahead of time, instruction pipeliner at runtime, decide that they can be moved. And atomics lets you control some of that. I don't want to talk too much about this because there's an incredibly good blog post. I just have to find it. And I have to advanced search it from me. No, I want atomics. Atomic? Oh no, oh, it's probably a acquire release. Yeah, okay. So one thing you want to do is you can always use mutexes and locks, of course, but that's slow. A mutex is global. That means all of your CPUs have to lock and wait for access to this piece of memory. So then there's this concept of what's called lock-free synchronization. We're going to plug this real quick. Love this blog post. This is an amazing blog post. Great job, Dave Killian, if you'll ever watch this. So what will happen is the different CPUs can agree on how memory can be acquired or released, and that's what this is, acquire release semantics. Yes, you can share memory in concurrency. Yes. Just one type of threading. Yeah, George, thanks for the explanation. This is just one type of threading problem. I love this. This is great. How you think memory works. So we're building a FIFO queue. We're building, in this case, it's a circular array. Love these. These are everywhere. We love them. You set a fixed size. You've got linear insert, O1 insert, O1 read if you're reading from the head or the tail, and then linear scan. It's great. So you want to create a lock-free producer consumer queue. This would be like a Go channel. So you want to build Go channels from the ground up. So you've got a head, a tail, and a size, and then some pointer to memory for entries. And you, in your put, you're going to write something there and increase the tail counter. And in your poll, you're going to check to see if you wrapped around you're going to grab that entry, or is it empty? Sorry, you're not going to see if you've wrapped around. You don't care if you've wrapped around. You're going to module into it, and you're going to grab that entry. Otherwise, if the tail, the reader, is ahead of the head, it's empty, and you can return false. This code is perfect, right? There's nothing wrong with this code. It's exactly how we would write it. We have, and this is C. So we have the location of our entry, tail module size. We place it there, and then we increment the tail counter. What could possibly go wrong, chat? Well, you have this bug. Where do we talk about it? There's a bug in this queue, and I'm wondering if you can find it. Poll returns true, but entry is still null. How is that possible? And what you have right now is you have two threads, the producer and the consumer. They're running the same code, but you know one's producing, one's consuming. The problem is that memory semantics say that you can call the put method, and then the CPU scheduler can actually call the poll method before the put method is actually written to entries. And this is why. Take a closer look at the toy queue put. Your CPU doesn't read and write memory. Memory is many times slower than CPU. So the CPU reads and writes memory through a cache, or if you're Australian, a cache. Maybe when running this code, it so happens that we get a cache hit for tail and size, but we miss on entries I. Now we're blocked. We can't execute the second line of this function until the memory contexts come into the cache, and memory is slow, and it might take a while. So the CPU rewrites your code sometimes. And what it does is it will, it may increment the tail because that's fast to do while you're waiting for the memory to come in for that read. So poll sometimes returns true without an entry because that's really the state of the queue. Tail says there really is an entry available, and entries I really just hasn't been set yet. But the CPU did this to us. So what do you do about it? What you have right now are something called fences, which are similar to locks but different. They just tell you where you can memory order your program, and this is concept in C. I believe Rust has fences. Yeah, it's got a fence. So these are how you can do a like a lock-free queue. Then there's this other idea of lock-free commands with relaxed semantics, where you can do what's called like a compare and swap, where it's similar to mutex in that you have a value, and then one instruction at one time can do that, or one CPU at one time can do that instruction to compare and swap two values, and that is guaranteed to be atomic. So you use these atomic libraries, atomic operations, and you can get lock-free synchronization, and it's very fast. And why are we talking about this? You have all used this. Everyone here in chat has used this. libuv is what powers Node.js, and it has this event loop concept of publishers and subscribers. So this is where this would be implemented. This is where this would be used. So remember when I talked earlier, folks were asking me about being a staff engineer and going a level deeper. This is what I'm talking about. You can have a long, successful career writing front-end, back-end, node apps, whatever, right? Never having dug in, or you can opt to learn more about how this works. And you can read about this, and you can learn about this, and you can work on this. And a lot of times it's true. The more you read, the more you learn, you're going to end up writing lower-level code because you're going to want to be interested in learning about it. It's great. You should do that. That is totally, totally fine. And I mean, I would encourage it highly. But this is the stuff that's available. MC function. You know what? Welcome to chat. Thanks for the follow. Appreciate it. And then, okay, the coolest thing though isn't even libuv. We should talk about. I can't remember the name. IRing, which is great. The only problem is that it's had a couple of vulnerabilities in some versions of the kernel, but it's been great so far. IRing is a new, faster version of Node.js, I should say new, faster, that's incorrect. IRing is another example of a way to increment or to implement non-blocking event loops. But the coolest thing is that it does another performance thing, which is it reduces allocations. When you ask the computer, when you ask the kernel to give you memory, it actually is expensive to do, right? It has to go off and find a block of memory and give you a pointer. When you call malloc, it has to go off, you have what's called a kernel mode switch. So your code gets written to memory and frozen. The kernel mode or the protected mode gets loaded into memory and executes. And then it says, okay, I'll go find memory for you. and it goes off and finds some memory, gives back a pointer. Then you have a user mode switch. Every time you do that, that's a couple of nanoseconds, and that's painful. At speed, like say you're processing, trying to do like 100,000 requests per second, every single one of those is going to do user mode, kernel mode, user mode, kernel mode, user mode, kernel mode, over and over again. What if you didn't have to do that? What IOU-ring does is gives us a queue that technically the memory lives in the kernel space. And then it uses virtual memory maps, or mmap, to virtually map that memory, a chunk of it, into a shared memory of the application. So the application thinks it has access to this memory chunk, and the kernel lets it. And the kernel also has access to this memory chunk. Now you just have to do the thing we just talked about, which is lock-free synchronization with a buffer, with a circular queue. And you can write work for the kernel, and everything we're doing to the kernel, think network requests. Every time I say write to the kernel, you're writing to, you're writing an HTTP response, or you're processing an HTTP request. So the submission queue is for responses, and the completion queue is for requests. Kernel reads off here, has a request coming from a socket, writes the bytes into its buffer. They're wrote just once, and then your application can read it. That's the benefit of IOU-ring compared to libuv, where libuv will have to copy those bytes from the kernel into the application and back and forth. You don't have to do that here. So I'm looking forward to the world of JavaScript runtimes, maybe Bun at some point. No, George, totally different from eBPF. Totally different from eBPF. We can talk about eBPF too. But effectively what this is doing is limiting the amount of kernel mode, user mode switches and allocations. And it's a huge performance improvement, like 40% or something in just raw throughput. Big fan of IOU-ring. Although, like I said, it had some security issues getting out there. Yeah, we're 5 rabbit holes deep. George, that's what I love about this chat. We're going to be 5 rabbit holes deep. eBPF, or Berkeley packet filtering, is a network level technology that lets you write a little C program that can interact at the hardware level at line speed with your outputs. Why do you call yourself an AWS hero? Well, I don't. They call me that. There's me. What does that mean? AWS heroes dedicate their time to help others build better and faster on AWS. Heroes support and give back to the community in various ways. Contributing, talking. I've given lots of talks. Yeah, so there you go. That's me. Click this, boom. Go to my little section. Blessed up kid. Bless up. Thanks for the follow. Do you also understand DevOps? I mean, I run a lot of stuff in production, so I would hope I could say that, but I wouldn't. I don't know. I've never really called myself a DevOps engineer. We're developers own their own operations at Datadog. Man, I should start clipping these up and putting them on YouTube. There you go. That's acquire release semantics. So we're 2 rabbit holes back. I guess if I'm going to do this on YouTube, I can't do the rabbit hole, and I do enjoy that. Anyway, fences, acquire release semantics. Where do you get, so yes, of course you can do locks, but you can also specify a fence. Yeah, so, and Rust has this too, memory order relaxed. So you can say, yo, I'm gonna do 2 things in memory that need to happen together. Similar to like you do a mutex. But then once you increment that value, you can say, okay, release, and then you can acquire that as well. But yeah, there you go. Atomics. Now you learn something about how CPUs work. We can retweet this. That's a great one. Oh, Tom shared this. Oh, this is cool. Okay, he sent this to me. Bum, bum, bum. Thanks, Tom. I don't know if you're in chat, but thanks. George, you feel like if you're practical about things, you just pick up random skills, whatever you happen to encounter. Yeah, I try to be really deliberate. One thing, I think one piece of career advice I could impart is to be deliberate about where you spend your time learning and where you spend your time working as much as you can. You can't control every project you get. But the goal is to, if the goal is to set up yourself as like an industry expert, which is sort of what I've been trying to do in a certain niche, then you sort of have to be deliberate about how you work towards these things. So yeah. What should we say with Tom? I think this is just great. Yo, blessed up kid, welcome to chat. I feel like I can't remember enough to get higher than senior. Oh, you totally can, because it's not about what you know, it's about or what you remember. Like you're not GPT. You're not Google. You're not being paid to remember stuff. You're doing like what I just did, where it's like, oh, I know about this. It's been a while since I read about it. I'll pull up the post and talk about it. Or you'll remember a project when you worked on it. So. Okay. Yeah, I use AI tools all the time. We use Copilot already. Cool. Okay. Sweet. Let's go back to this. I'm having fun. Okay, so we want to make sure. All right, we're winding back the stack all the way. We talked about atomics. We talked about acquire release semantics. We talked about Rust. We talked about a little bit about eBPF. Now we're back. We're all the way back, rewound, we're at CloudWatch. We ran our little Rust script. We are gonna just make sure that we've got this right metric. What is the payload? What do we call that? So we just gave it a metric name. So it should just be, okay, so the namespace is AJ local metrics. So we click metrics, AJ local metrics, metrics with no dimension, Lambda plane. Okay, yeah, so we're using this name. Boom. Hey, we got our point. 399 milliseconds for a Lambda plane. Okay. What's next? We have all these functions deployed as environment. Oh my God. Butt plug Betty. Anonymous, thank you for the initial gift. Congrats on your free sub. Wrap it up and get the answer. $3.99. Yep. Kojak, that's just base Lambda round trip from Lambda itself. That's Lambda calling itself. But now we got to build this out. So let's write some code. We want to read these from environment variables. And we should make a method, and we should. Okay, so we should have a little bit of borrowing here, because we're going to create a struct of these hashes, and of so let's do fn, not func. Copilot is going to suggest something right away. Main. It's not main. URLs, and this is going to return a hash map. So you see how it's suggesting these lifetimes for me here? So that the apostrophe and then static is just telling me it's going to live for the life of the program, which it can. That's fine. But anything after an apostrophe, traditionally you would do like a single letter and you would go alphabetical. That's a lifetime. And that just tells Rust compiler how long something will live for. And in this case, all it's saying is I'm going to pass this back to the caller. So the caller has to make sure that these strings are static and live as long as the program. What hash map are we using? Collections, yeah. And this can, we don't, so the reason it's doing that is that these are string slices. Will it complain because I removed static? Yeah, okay, it will. So the problem is that these string slices need to live somewhere. And if I don't have a lifetime here, if I don't tell them that it needs that that lifetime, then it will fight me and be complainy. And that's fine, we can use that. But now we don't want this. We just need, oh, what do we got? Deagle TG, thanks for the follow. Welcome to chat, thanks for hanging out. Okay, boom. We got our lifetime. Now we need a new hash map. Let map. Oh, you know what else we could do though? What if we didn't want to do this, chat? What if I didn't want to? So this would be, we're going to make this function. We call it with nothing, and it gives us back a hash map. So the borrow checker says, yo, you got to make sure that whoever gets these is going to take over caring for them. It's going to water them. It's going to, give enough food and water for that little hash map to grow. No, I'm kidding. It's gonna make sure that it looks after that memory reference, and it drops it because these strings, I'm pointing with my finger like an idiot. These strings are string slices, and that means that they are allocated on the stack And now we have to push them back somewhere, so they have to store them somewhere. Now, what if we did, we could avoid this though. What if we just return back the same hash map? And we said, function, why are you not storing them in .env? We will, Scala, but we need to parse them into memory into the application. So now, what do we need? We don't need this lifetime anymore. We shouldn't need this lifetime anymore. Oh, we need to at the very end, function map. See, now it's not complaining. Why is it not complaining? It's not supposed to complain. Well, maybe it does want this. Oh, because it's got 2 lifetimes here. So we can say, fine, we do have to specify our lifetimes. So now it's okay. You can also, but we can also use that URL for AWS Lambda plain. Yeah, we are going to. This is just my little test function. But we want to read these from environment variables. So what were the environment variables we called? Here. Something else I found is that here's another way I use ChatGPT. Say I'm writing this code, or I'll use Perplexity in this case. I can just say convert from Node.js to Rust. This is fine. I've done this before all the time. This is great. What's wrong with this? This is totally fine. Now, it did change our semantics a little bit. We have, first off, lazy static. Sure. We don't have to use this macro. We don't need a static ref. We are returning a key, which is stack allocated, and then a string, which is going to be heap allocated. That's fine. That works just fine. Oh, wow. We just crossed over 400 follows. 401. Deagle, you were the 401st follower. Blessed up, kid. Bless me with my 400th follow. Thank you. Neither static nor strings matter to me because this hash map is going to live for the life of the function. So it just doesn't matter. It's gonna call once, it's gonna insert it, and then it's done for forever. So we can do it this way. That's fine. I care way more about this. How do I want to do this? What's the fastest way to do this? We just need this code. We don't need any of these other ones. Don't ask for a follow-up. Hello world from Paris, Scala guy. Thanks for the hello. Datadog has a huge office in Paris. I've still never been. Use SCD. Use standard env. Consider borrowing here. We can return this. We can also return strings. Oh, I've interviewed it. Failed at systems design. Yo, I mean, low key, like the systems design is probably the toughest one, and you gotta really hustle. Cannot borrow as mutable. Oh, for AWS, it doesn't like it. Oh, mute. Okay, so what was it complaining about? It said, okay, here's another thing. Rust, every variable by default in Rust is going to be immutable, which means you can't change it. But I'm touching this map. I'm putting stuff into it, so I have to make this a mutable reference. There you go. We did it. We fought the borrow checker. Yeah, scalable notification system within AWS. Serverless is good for that if you can, make the case that you're worth the added cost. I use serverless in my systems design interview. Use some Lambda. All right, Tom also, I just replied to Tom in another window. Tom also said, whoop, we should do a Next.js test. Absolutely, we should do a Next.js test. I just wanted to try out their new Rust wrapper, which I think we've done pretty successfully and learned a lot. Blessed up. I love working at Datadog. I have no complaints. obviously I've learned a lot of this at work, right? Like I've done a lot of this stuff at work. So this has been, huge part of my career. Love Datadog. Strong recommend. Okay, get function URLs. Bum, bum, bum. Let function URLs equal get function URLs, and then we need to pass it a hash map. Cannot move. Oh, because this is a string. Does not implement copy trait. It shouldn't need to. Yeah. Okay. Here's another great. Hold on. Where's the repo? Donnie Martin. Oh, sorry, chat. I yelled. I'm really sorry. Headphones users, I'm so sorry. Yo, my bad. Oh no, numbers are imploding. Everyone's leaving. I apologize. Love this. This Donnie Martin system design primer is great. A lot of really good examples here. Some of these are maybe a little dated, but it's a great place to start your learning journey. So if you're struggling with system design, or you're learning it, there is so much information on here. I think it's a pretty solid guide. I'm a big fan of this. And any of these conversations you can build on and add your own information. I do think some of this is a little high level. This, you couldn't drop into like a senior interview and just draw this and be like, I'm done. You need to talk kind of at great detail about something specific. When I interview folks, I try to figure out what, especially more senior people, they generally, even like early mid-career engineers, the level 2 or senior engineers, have gone deep on one of these things, right? One of these things, they've gotten burned by it or fought it or had some issue, and they know it well, right? Maybe it's a backend developer talking about building a timeline service, and they can tell you about time zones and why they're really hard. And they can talk about keeping up to date with the IANA time zone list, or what happens when, countries change their time zone, which happens all the time, by the way. That's a really great question. Or people that have done, if you've done a replicated SQL store, you've got like a primary and then followers. George, do you not know this? Yeah, all the time. So TZ Announce is the mailing list you should read. They release this every couple months. There's changes. Yeah, tons. And I used to be subscribed to this email list when I worked on an event store. And by events, I mean like scheduled like calendar events all over the world for a company. And this was actually a problem. Like what happened when we had stored 500 upcoming events for the next 10 years for a company, and then the country they were in changed their time zone. What do we do? It is a painful thing. So yeah, you can download this for the actual information. No, this is a list of all the time zones countries observe. So you consume this as libraries in the same way we were talking about system code, like we were talking about IRing and we were talking about libuv. Like your library, like if you're using oh god, what's the time and date library? Moment in JavaScript. Moment will use this database behind the scenes, like in your code when you call. Yeah, it'll be there. When you ask for something to in like, what time is this UTC timestamp in whatever. Space Motion found your, hey, welcome to chat first. Thanks for hanging out. Found your graphs on Twitter. What was the cold, yes, this was a cold start performance on, well, we're comparing all AWS in this case. Vercel is hosted on AWS. But yeah, we're making this request from a Lambda function. And we're doing that because it's in the same, at least in the same region as where my Vercel function was, which is US East 1. So yeah, that's how we were getting that information. This is the graph, very pretty. And we did use a trimmed mean, which I haven't tweeted about yet, but I should. My stats friend said to use it, and it makes sense. I mean, when I look at performance improvements from our own systems, I often look at trimmed mean. What was the cold start of this Lambda? So this is a invocation of a cold start, which is also end to end. We have to use end-to-end latency because the reported latency in CloudWatch, the init duration metric, that does not include the time it takes to copy the bytes into the sandbox, which means that you don't get a full picture of your cold start. Bouncy Deers, thanks for the follow. Welcome to chat. Thanks for hanging out. And yeah, hey everyone on YouTube. 10 of you over there now. Whoa, hello. Thanks for the follow. Using Fastify. Fastify is great. I don't know. I haven't tested Fastify. I haven't actually tested this in the harness. We could set that up if we wanted to. But I want to get this going first. Okay, so we've got all these environment variables. Hey, Nokella. All right, changing the topic. Can you tell me about your opinion? Space Ocean, thanks for the follow. Having multiple -f flags on Docker Compose. I am not an expert on Docker Compose, so I don't know if I have an opinion to weigh in there. I mostly run one container at a time. I haven't had to. Well, that's not true. I have a library that I maintain has a test system that uses Docker Compose, but it's a test system, so I don't really care about it. If you're running it in production, you're probably not running Docker anyway. You're probably just using the container as a way to, register and store information. To maintain support for deprecated APIs and ensure backwards compatibility, do you deploy functionality within a separate method? Can you expand on that, Scala guy? What test are you making me take right now? That question has no context. We have to deploy a whole new fleet of these before we can get this test rolling, because we need local. We should actually add that to local, because I don't want to screw this up. Oh, yeah, you can do both. I've deployed separate functions. It depends what I'm doing. If I'm first off, if I'm changing the API envelope, depending on how big that changes, I might do a different function. But if it's a small one, no, I'll just do a conditional on my back end. And it depends on how fast you can make your clients move. One of the benefits of working at a startup is you're usually your own client. So you can do a breaking change in 2 pull requests, right? You ship the condition. It's like, if old wrapper do this, if new wrapper do this, then you go to your front end team, or you are the front end, and you go there and you say, okay, we're going to go to the new one. And then you can delete the old stuff. Then you have to do that. Here's the thing, man. You have to do that for columns in your database for a highly available service anyway, because during deployment, you can't drop a column that everyone's using, right? Or you can't you add a new table, or new tables, additive changes are always fine. But you basically need, you got to put you have to handle the fact that one version of your code, your old application, is going to be using the old code for a bit during that deployment, during that rolling restart, because you're going to have some nodes that are going to be running the old version and some nodes that are running the new version. So you got to do both at once. That's pretty normal, pretty typical stuff. Oh no, Vercel old runtime. Okay, sweet. Now we have to deploy all these. Oh, for sure. Space Motion, my app has 1 million requests per day. It has a 1-second cold start. Yowza. 1 second's actually not too bad, but it depends what it is. What is it written in? What language? I can give much better advice if I know what runtime you've got. Some of the advice might be I can't help you. There's only so much I can do for my Java friends. Snapstart will get you to that. Yeah, if you're Node 20, okay, so a few things you can do on cold starts. The first thing you should do is look at what libraries you're loading. So I wrote this blog post a while ago. We'll plug it here in chat. The first and most important thing is to know the code you load. So one of the most popular products I think I built at Datadog was this cold start tracing feature. What this allows you to do is see all the dependencies your handler loads. So in this case, this handler loads the entire V2 SDK. And you can actually see all these dependencies and how long they take. And this is during a cold start, so your customer's waiting for it. So this was a 1.24 second cold start. Well, yeah, of course it was huge. It spent 233 milliseconds or 223 milliseconds loading all of the Lambda clients, or all of the AWS clients. So you can get a much better result here using something like ESBuild. That's pretty helpful. It's not entirely helpful. We did that here. You still have a pretty painful cold start if you load everything. But if you do a tiny one and you minify it, it's pretty fast. So I would recommend you look at something like this, like cold start tracing can help. This code's open source. Yeah, but that's still 1 second is pretty painful for single ESBuild. So I would look into your ESBuild config. ESBuild has a bundle checker. bundle analyzer. Check this out. I would drop your meta file in here, and it'll tell you, it'll give you a flame graph. This is all day what I look at. Yeah, provision concurrency helps. That definitely helps. Scala Guy, what AWS services are considered part of serverless architecture? Anything that has a pay per use and not just pay by instance, and then anything that kind of scales up automatically and scales down or off when you're not using it. That's what I generally consider for serverless. Scale to 0, scale to infinity, pay for only what you use. That's mostly what I say would be serverless. Italo Casas, thanks for the follow. Welcome to the chat. Thanks for hanging out. Boom, boom, boom. All right, I promised Dylan. I don't know if you're still in chat, Dylan, but I promised that I would get this working. Let's get this rolling, and then we have to. Okay, we also have to. Something in my back just cracked. We also have to get it running on this little guy, and I don't know how that'll go. We're gonna want to plug that in, but we will see. Okay. Sweet. Okay, so first thing we have to do is redeploy all of these to get a local version. P. Bertrand, returning chatter, suspicious flagged. Why did you release another benchmark? Now I have to update my serverless rock, paper, scissors. It's Bertrand. It's because I needed to drive users to the stream. I'm kidding. We set this up last week, man. That's why. I got to drive viewers. We set this all up last week, and we just had to collect data. This is OG, Sir Bradley. This is the Raspberry Pi B, circa 2011. Look at that. Huh? This is like, I think it was the very first one that had HDMI. The other ones, y'all, some of you are probably too young to even know what this port is. The video port, just this little RCA port, the yellow one. Analog video. Bertrand, yes, you're obviously suspicious. It immediately flagged you as suspicious. God, is this even gonna boot up? I'm gonna have to find. This is gonna be fun. This is gonna be so fun. Data ingestion, transformation, and storage. Oh man, we should do a whole stream on. I could do like a whole week on distributed systems. There's a lot there. I guess my best advice, Scala Guy, when you're building on Lambda, you're building a distributed system. It is going to run concurrently. It is going to run multiple copies of itself, and it's going to run in multiple regions with different latencies, or multiple availability zones with different latencies. So you're going to have all of the consequences of CAP theorem, consistency, availability, partitionability, pick two, are going to apply to your applications. So that is probably my best advice. Like, you have to consider all of these. You have to consider things like idempotency and retry and what we would call like at least once semantics. So you have to build all that into your application. Griat, welcome to chat. Thanks for saying hi. What age did you first start learning to code? Oh, my fingers pushed the keyboard and wrote HTML maybe when I was 12. But I didn't learn anything about building software until I was in my mid-20s. I barely made it through college, did not write much code. Most computer science programs, you don't write that much code. I did not do well, and I learned at work. I had very gracious mentors and patient people. Oh no, it's AJ, that guy Doru, the Ruster. Welcome to chat. Thanks for saying hi. Thanks for the follow. I went from wanting to learn Rust to learning that I'm rusty. Yo, Rust for Rustations. Let's go. Signed copy number 10. Okay, we got to redeploy all this infrastructure for a local version. So let's go ahead and do that. Did I start? No, I didn't start any more Vercel drama. How did it feel? Everyone at Vercel is really nice to me. And I think I've been very kind and honest and forthright. So I think it's been fine. I don't know. Like, I didn't know, I spoke about this at the very beginning of the stream. We talked about Prime's video for a little bit. I didn't know that a lot of that had happened. Like, Dax had tweeted it and he told me that there's like stuff going on. but I had no idea that there was like a bunch of stuff like all flying around between some of the folks at Vercel and just like other people at the internet. And I also didn't know what was all said. Like my whole point was I wanted to test this. Yeah, thanks, Dylan. Yeah, no, everyone, I mean, Lee Rob and Guillermo, like people have DM'd me and said nice things. And obviously like Dylan and Tom have like sent me notes on feedback for the benchmark. It's all open source for a reason. It's not open source because I like want you to look at it. It's open source because I want people to like give me feedback on it. And I've gotten a lot. So we've done a lot of changes. Scala guy, past struggles with formal education, substantial learning, professional settings. Yeah, I didn't learn any software until, like, I didn't really learn how to build software until I was working at a startup. Hey, Da Phenomenals in YouTube chat. You can't see the chat. Sorry. There is, you should be able to see it on the stream above me. It should be in the video here. It's live. Let me see if it's live on YouTube. Yeah, I see the words screaming. YouTube chat is over here though, so you won't see yourself chat, but I got it. Learning Swift. Swift's a great language. I think Swift to Objective-C is way better. Also, Scala guy, like I said, I learned software so I could build things I wanted to build, and then when I wanted to know why I couldn't improve the performance or why I couldn't make it faster, then I went a level deeper. And that I just continued that over and over and over and over and over again in my career. I went a level deeper and I learned again, and I went a level deeper and I learned again. And eventually you end up, in assembly and Rust. And the other cool thing, one second. Dax is asking me questions about the environment variables. Yes, we added environment variables. Da Phenomenals on YouTube. Oh, he can't see his own chat. Wants to know about learning distributed systems and network stuff. How do I find a job? You have to find a company that needs to build a distributed system. So Datadog does, because all of our distributed storage systems are all like distributed by default. But if no one wants to hire you for that, go and do what you can get hired for. Like learn. I built a Ruby on Rails application for registering youth and amateur sports teams, and that's what I learned, how like the basics of the web on. So start there. Start wherever you're gonna get paid to work, and you can learn. Go, and you can learn stuff anywhere. Like I do believe in what Gary Tan said about like learn or earn, and if you're doing both, great, but at least do one, otherwise bounce. But I truly believe like no one's gonna spoon feed you this stuff. I mean, I will on this stream, but no one's actually gonna spoon feed you this stuff. You have to get out and like learn it. You have to get out and read it. Like read the papers. Like go out and print some papers, take your highlighter, sit in a park, put your phone away, and read a paper. Or print a blog if you get distracted, if you have some of those issues with your attention when you're on the internet. Like print out a blog post and take it to a park and read it, because that's where you're going to develop that learning and those muscle memory. Oh, Deagle, I don't know if I have my LinkedIn set up, but y'all, I'm on. It's just my name. Yeah, real name AJ here. Boom. You don't need an exclamation mark name, Deagle. It's right here in the channel you're watching. My name's AJ Steivenberg. Okay. We need to redeploy a bunch of these apps, and then we can talk more. So we need to Vercel plain function, local Vercel plain function. We'll have to nuke the git rf.git git init. Okay, we can set that up in a second. Let's do the rest of them. I think it may be in our stream scratch. Oh yeah. Yeah, go ahead. And also you can always DM me. You can DM me on LinkedIn. You can DM me on Twitter. Where did all these directories go? Are they in stream scratch? Delete something important. Okay, yep. All right. CD stream scratch. There we go. Okay. Lambda Hono. Is it Hano or Hono? So I'm just creating copies, so I have the exact code everywhere, but then I don't accidentally deploy one over the other. It's easy enough with serverless to deploy to two different places. That's not a big deal. But I don't want to inadvertently clobber one. Octagon. Oh no, welcome to chat, Octagon. Node container web. Did we do node? No, we didn't do that. Yeah, this is our wrapper. Okay, so this is just the plain Lambda. Do we call it that? Actually, should we? They're namespace, so it doesn't really matter. But we'll, yeah, this is fine. And they're all Node 20. They're all. Oh, I have to upgrade my Vercel. I have to upgrade my Vercel plan. Dylan, I'm gonna send you guys some money because I need to use gigabyte or 1.7 gig functions. Spend some dollars. Thank you, my family is starving. You got it, Dylan. Amor, I'm drinking red water. It's Mio. It's just, yeah, I like a little flavor in it. Okay, CD, local, Lambda, cold start. Let's get this. Let's get these deploy trains rolling. Chat, let's get these deploy trains rolling. Export AWS profile equals server or personnel. Okay. Is that you flying the About Me page? Yeah, Explorer. I'm also a hobby wingsuit base jumper. It's all on the same channel. Maybe that's bad for YouTube, but you can watch my base jumps. Live now, by the way. Yeah. Okay, Deagle, you're right. Oh, Griat, thanks for the sub. Appreciate it. Deagle, you're right. I need to add a bunch of this stuff. Yeah, here's a wingsuit base jump. This is from the IRing. This is a while ago. This is from, yeah. So yeah, you climb this mountain, then you go to this formation called the Mushroom, and you rappel over. Yeah, Gorge. I've been to VA Gorge. Welcome to chat. Thanks for hanging out. I've been at Twin Falls every single year, save COVID, since like 2012. Been going for a really long time. I've got lots of videos from Twin Falls in these videos. So I think this is a wingsuit jump. Explorer, thanks for the follow. You can see how sketchy this is. You have to like reach over, clip on this rock. You're 5,000 feet in the air, by the way, and then you can rappel over. They used to jump this. Deagle, you learn to wingsuit the same way you learn everything. You start slow. You start skydiving. Once you've got 200 skydives, you can start wingsuiting. You do that from the air a bunch. I had 700 skydives, most of them wingsuiting before I took one off a cliff base jumping. So here it is. I think this is a video. Yeah, so that's me in the suit. You have to skydive. That's the only way. This is the only way you practice. This is the only way you get better. So yeah, I think the video from my channel is a clip from right here. This is a good way to fill deployments. Yeah, you can do wind tunnel, but you can't. There's one wingsuit wind tunnel and it sucks. And then you just, well, you remember your visor, and then you jump. Looks like that. Boom. And then you fly. Yeah, you can practice skydiving in a tunnel, but you gotta just, for base jumping, a lot of what you need to learn is canopy control, and you can't do that in a tunnel. That's what it looks like. Whoosh. Sorry, headphone users. Yeah, and then you just fly and fly and fly, and then you pull the parachute. It's kind of a long and boring flight. And the parachute looks like this. I'm still so high here. Probably 1,000 feet. I've done base jumps I've literally jumped from lower than that. Yeah, this is all solo. Yeah, you have to be, you stretch your body to hold the wingsuit stiff. All right, I'm gonna go secret mode here because I have to record this URL. Yeah, base jumping, there wasn't really any option for a while to be trained. So yeah, you train yourself. What do we call this? Local cold start Lambda. Okay. All right. Fuzzy mode, no problem. Yeah, so I've done that for a long time. Now I've got a baby coming, so I'm probably not gonna base jump. Not gonna base jump till she's a little older. I'll base jump at the bridge. The bridge is pretty benign, pretty safe. But I would say there's like, yeah, a lot of danger in the sport. Shrestha PY Shrestha, thanks for the follow. Congrats. Yeah, we're expecting a baby here in July 25th. Oh no. Okay. We need to. Oh, did I just deploy over that? I may have. Shit. I forgot this is a CDK app. How did this end up? It was called Lambda Hono. Oh, how did the resource end up though? I think we can just rename the stack. Ciao from LB, AJ. Cheers for your time. I'm out. Thanks, Micah? Max? I don't know if I could pronounce it, but thank you. Welcome to the chat. Thanks for hanging out. If LB meant Lauterbrunnen, I would be so happy. Lauterbrunnen was where that video was just from. Shout out Lauterbrunnen. Index. So yeah, we just have to use, okay. It does? Really? I wonder if maybe we've met. I don't know. Dinner time. Enjoy. Go enjoy the Alps for me. I miss it dearly. I've only gotten to go to Switzerland 4 times, and every single time I went to jump. I wondered if I might have a viewer hang in, like come hang out from who was also a base jumper. So we got to call this local Lambda Hono stack. Okay. Lib Lambda Hono stack. Lib local Lambda Hono stack.ts. Rare breeds. Yeah. You can't tell me Lauterbrunnen isn't just awash with young, dumb 20-something dudes trying to learn how to base jump. I was there. I remember what it was. I remember the very first time I walked into that valley, I thought it was magic. And then like by the time you're the 5th time, you can like, you see people, you're like, oh, you're gonna come and jump once and you're done. Some people just don't last. And I don't mean they like get hurt or anything. They just like try it once and then try a different hobby or whatever. Sorry. Nvim bin. What do we want? Lambda Hono. So it should be local Lambda Hono stack. Okay. Man, I'm so jealous you get to live in Lauterbrunnen. What do you mean? Oh, because I didn't name it. Nvim lib. Hang at the Hornet. Oh man, I haven't. You're bringing back such rich nostalgia from that stupid pub. This should be all ready now, right? Bin Lambda. I mean, great. Like, I wouldn't trade anything for my time base jumping. Base jumping has been an amazing experience. Maybe I don't consider myself a jumper so much anymore because in the last 12 months I've done 40 jumps, so that's a little bit. But only at the Perrine. I used to go every year, do the loop. You do the Prime Bridge in the spring, get warmed up. All summer in the winter we just jump antennas, and then all summer spend, your max Schengen visa in Europe, and then in the fall come back, go to Moab for Thanksgiving. Those were the days, man. I love it now though, don't get me wrong. Like, life changes. Can't wait to be a dad. I think we can just deploy this. Okay. We're gonna have to go fuzzy again if this works, because I need to get the URL out of here. Yeah, see you. Enjoy dinner. Oh no. Okay. So it did want to create a new stack, or it didn't want to create a new stack. No changes though. That's fine. How do I make CDK create a new stack for me? Oh, it just says, okay. There's got to be like a CDK cache, right? Is there a stack name? Why did I use CDK for this? CDK rename stack. How do I do this? I don't care about renaming this. I want to create a new stack. Yeah, this is an OBS trick. This is just there's an OBS trick to do like a diffuse pattern, and I just do like each pixel split in half basically, and then mirrored. You could technically reverse it if you wanted to. It's not actually even a password. I'm not even hiding. I just hiding the URL because it's like a public URL, and I'm gonna be hitting it with my curl script. I don't care so much about the like Lambda because it's throttled pretty low, but I just want to make sure I can get data from it. So if someone actually grabs it or wants to be nefarious, then yeah, it would be kind of ruined. Why is... Where is CDK holding its... Is it info? Oh, here we go. It doesn't have... It shouldn't know... Okay. Where does that come from? Oh, it is... Okay, so we just need to remove this. Okay, so we need to do lib or local. Will this change it now? There we go. Okay. Let's just do rm cdk.json. Now it should give me a new stack. Oh no. Okay, so cp./lambda. We deleted the thing. Yes, the code for this is on GitHub, Shretha. cdk. Oh, here we go. Yeah. I think we just want to remove all of this. Okay. And this should be local. mv bin. Okay, that was too much work. There, now it should tell me it's not been deployed yet. No, why is it still Lambda Hono stack? It's still using the same stack. Oh, it's package. Oh my god. All this local cache stuff is killing me. Tab autocomplete, let's go. Local. Oh, the test still says this. That's fine. That's just the test. That should be fine. Package.json, local lambda hono. That sounds good. Oh, it's because of this. Now? Did we do it right? No. It's like attached. It's just... CDK is being a pain. I just want you to create a new instance of this app. That's annoying. How do I make you do this right? No, this isn't what I want. What is CDK synth going to tell me? If it's going to deploy to that stack, we're going to be fighting. Oh yeah, it's got all the same metadata. How does it know? It's got to, I got to break it. We have to break it somewhere. David Wells, welcome to chat. I love the infrastructure code that's only deployable once. You know, oh, this is a message from YouTube chat feature. They could just have a thing that's like, I want to copy this entire stack and give it a rename and tweak it. And that feels like that should be easy enough to do. But all this shit is magic. Can we re-init this? Oh, it wants it to be an empty directory? I don't want to copy everything over again. Fine, we can do this. Let's just rm.rf local lambda hono. Make dir local lambda hono. cd $bang. cdk init app language. Where's the pixie dust? It's all magic. Oh, all this crap has to get copied now. Bin and lib and stuff. cp / lambda hono. Oh, that's going to be such a pain, actually, because I have to move all the packages over and everything. Okay, we're going to skip this one for now. Because we have to do a bunch of deployments, and I realize now I'm probably going to be out of time to do everything on Raspberry Pi today. But let's just do, what are the other ones we have to do? Lambda web adapter. We weren't using the, what was my repo? Repos, Lambda web adapter plain function. Where did is that what I call this? Okay. This looks like it, yeah. Is this the right app.js? Yeah, okay. So this we can at least copy. Okay. Whoopsies. CP-R. Serverless framework, David Wells. Thank you. David used to work on the serverless framework before I ever did. Local. Look, now we have a whole other copy of our infrastructure. Look how easy that was. Okay. Serverless for the win. Okay, we're gonna go on fuzzy mode while this deploys. There we go. Now at least we know we're gonna have another copy. We're gonna have a different function URL. It'll be totally safe. And we can plug that into the new Rust function, and then we can deploy it on this guy, on this Raspberry Pi, which is gonna run for a week. And then we will be able to see what we get after it sits. And we'll have another tweet we can share. Shout out YouTube. Thanks for hanging out, David. Appreciate you being in chat, man. The deploy is almost done. The serverless enjoyers can see in this my mouse in this little bit of the screen. That's the deployment spinner. Thanks for the follow, Gaziberg. Thanks for the follow. Thanks for hanging out. So what we're doing, we're redeploying all the same functions that we tested over the last week, but just a simple copy of it so that they don't interfere, because we want all the cold starts from last week to continue happening for our benchmark, so we can compare the latency from my home, which will I mean, it'll be different, but again, we're gonna have a benchmark, or we're not gonna have a benchmark. We're gonna have a baseline, and our baseline will be just a plain empty Lambda function. So yes, there is some network latency. We can make the request at the exact same time. We can do it concurrently. So we get the same route, and we can see. Okay. What did I call this? Lambda web adapter, local cold start LWA. Local cold start LWA. Okay. Scala Guy, the first way we minimize latency is by testing this within Lambda itself. So by using another Lambda function to ping this Lambda function, we're in the same AZ. It does, as far as I know, it does go out to the edge router for US East 1 and back. So it does have some network overhead, of course, because they're two completely different machines and probably physically separated. They may be in the same rack. We don't know. So that's one way we can minimize it. But the Vercel folks wanted to also, they mentioned that they put a CDN in front of their Lambda functions, which is fine. And again, my opinion was that's just part of the product, that you have a CDN and a web application firewall in front of everything. Not everybody needs that or has that, but fine. We'll do a comparison from my home internet over a week, but I bring my laptop to and from work, so I needed this. I was really hoping Synology, I'm trying to partner with them on this project and a few other ones I have in the pipeline for this stream. And we've been talking, and maybe we'll get a Synology device that we can show on stream and use for a home lab for a couple of projects. They've been super cool so far, but we just haven't gotten far enough, and I need to get this project rolling. So, okay, so that's done. We did the Express Lambda web adapter. What else do we have to do? So let's look at our metrics. Which ones do we check off the list? So we've got the plain function for AWS. We've got the Vercel. We've got Lambda web adapter. Now we need serverless HTTP. Oh, this is actually the serverless HTTP library because I worked on it. Is it serverless express? No, that is Vendia's serverless express project that I also helped work on. I could have organized myself this a little bit better. None of those are it. What did I call this? Oh, Lambda serverless HTTP. Okay. Yo, I'm Yeezy. Thanks for the follow. Okay, I'm pretty sure it's Lambda Express Web Adapter. Yeah, this is it. And let's just confirm. Yep, this is our result. Oh, wait, no, that's one we just did. Not, it's Lambda NVIM Lambda serverless HTTP. But same thing. Same exact response envelope. Okay, so cp-r $bang to be local Lambda serverless HTTP. Okay. Oh, not ls, local Lambda. Okay, local, do this. Everything else is the same. Bum, 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 bum. Just handler, right? Yeah. Yeah, no other name here. Okay. This should be ready to rock. Deploy it. And no, not deploy you. Okay. And we'll go back to fuzzy mode. We'll get that URL. We'll get it in the environment file, and then we'll have to... How am I going to copy the CDK app, chat? That is wild. That is so frustrating. I guess we have to copy it like one file at a time. That's super annoying. Didn't they? I think they did this example, yeah. I guess, okay, what we'll do, chat, we'll just copy it from their template again. So we'll start a brand new app because I forget which parts we changed. This is easy to fix. Yeah, this is easy enough to fix. All right, we can go fuzzy for 2 seconds. Is this done? Not yet. Apple and NeoVim, hell yeah. Yeah, we We have the option at Datadog to choose a Linux laptop, a Windows laptop, or a MacBook, and I think the MacBooks are most popular. A lot of our Foundation DB folks and like the hardcore distributed systems developers are going to use a Linux laptop though, which I get, because like if every day you're working with like writing your own database, you're going to want to be at that level anyway. George, a lot of the .NET developers use Windows. Local cold start serverless HTTP. Boom. Write that file. Done. I always forget about .NET. No one sleep on .NET, man. .NET kind of slaps. It does. It's got one of the fastest HTTP implementations. It's got a bunch of really incredible work that went into it. So yeah, mad shout out. .NET's great. I never in my career wrote it, so I never had to. Never had to. Okay. We gotta just get this. Okay. I gotta get this done. Make their local Lambda. Hold on. Okay. Start from scratch here, folks. This actually won't be so bad. David Wells, appreciate that vote of confidence for serverless framework. Lambda, Hono, Lambda directory. Okay, so now we've at least got Lambda done. Now we have to just edit the stack itself. So now we have to do admin dot lib local Lambda Hono stack tabby slash Lambda Hono lib Lambda. Okay, so this is great. Then we just have to call it local. Bam. Whoopsies. Local. That wasn't so bad. Do we do a chat? Oh, that wasn't so bad, chat. Okay. Let's roll this deployment out. Oh, and first I have to make sure it's not that same stupid stack, which it won't be. Yeah, it's a different stack. Okay. Version 6 required. All right, fuzzy mode quick. Oh, wait. Ah, yeah. Okay. Fuzzy mode while we deploy this real quick. Oh, actually, this one doesn't output a URL. I have to copy it. I'm going to use the bathroom. I'll be right back. Joyce, you're in charge. Right. We're back. This deployment finished. We gotta just grab the URL. I have to grab it from the function URL in the function, so hang tight as we stay fuzzy. Local Lambda. Oh, it's not called that. It's like... There it is. Local Lambda Hono stack. Boom. course it works. Okay. All right, I just gotta add this to my env file. Okay, boom, we're live, we're back. We've always been live. Okay, so what I've done is I've got in this other tab a bunch of these environment variables. The only other one we're missing now is Vercel, and we don't need this one because we're gonna just use the new stuff. So let's get this deployed on Vercel. What is my, how do I list my local or my remotes? You know what, it doesn't matter. Create a new repo. I forgot how this works. Shout out to my buddy Craig, who's gonna hang out with me right after this. All the way from here, South Boston. Thanks, man. Okay. We created the curler counter. That was a project we just wrote in Rust. Now we need this local Vercel plain function. Chat, you know what we're gonna do? We're gonna create an MIT license like we always do. Get remote add origin, bam. Use the beer license, surely. We could do that. We've been using MIT, but we've made a couple of our own additions. Choose a license template. This is the official way to do this, by the way. I had to Google this. I was like, how do I add a license file? I know you have them. You have to type the word license into the new file, and then it prompts you. MIT, review and submit. Plus, you have to follow me on Twitter, like, subscribe on YouTube, and follow me on Twitch. Okay. That looks good, chat. That license looks great. Email address leaked. That's fine. It's on my website. Cool. There we go. Looks good to me. Push to prod. Yeah, that guy Doro, we hit it straight to prod. Absolutely. Absolutely straight to prod. Okay. Now we got to install it. And oh, I'm gonna have to add my credit card. Vercel, projects. Your trial has expired. I will have to upgrade because I need that. I need that CPU. I need that sweet CPU boost. No, it's not a third party, but we need to add another one. Oh, but I can't, right? I need to upgrade first. Is that it? Okay. Hold on, we're just gonna go fuzzy. Actually, I'm gonna go fuzzy and bring it to a different monitor because I'm pretty sure you folks can reverse this if you really tried. Come on, 1Password. All right, $20 a month. We're giving the folks at Vercel. Boom, $20 spent. You're welcome, Guillermo. Congratulations on your latest round. Dylan, helping you out, man. Gotta juice those metrics. Can I not import the new project? How do I do this? Oh, I have to, there we go. Okay, now it works. Boom, we're gonna add our project. Oh, we got a 2FA here. All these layers of security, folks. You wouldn't believe. Okay, we gotta get this deployed. We gotta let it sit and bake, and then we have to, it'll have to be tomorrow where we deploy the Rust project onto our Raspberry Pi. Because I realized I don't actually have a power supply for this, and it's gotta be up. Okay. Sorry, we're just installing Vercel's application into my repo. Save. This is great. Now we should have it. Here we go. Perfect. Okay, we upgraded. All right. I'm also going to go fuzzy here because we have to give this a random name. Random. Okay. I don't, because these URLs are guessable. Sweet. Okay. The build is starting. All right. Okay, so what did we do today? We looked at all the metrics from last week. This is the last week of these metrics. These are going to keep rolling. We're going to just keep counting these. We're going to stick by these. Let these go. We're going to plug our we have to, tomorrow it'll have to be, we're going to have to copy my Rust application. We'll clone it from GitHub, and then we'll copy the I don't know. Oh man, I got to compile because it's like a weird ARM chip, isn't it? Like ARM something v2. We'll have to figure out how to compile for this, which will be a whole adventure in compilers in and of itself. And then we will let this bake and let this record points for us for the week. And then we will be able to tell you folks what the latency looks like from outside of Lambda. Thank you again so much for hanging out today. If you are new here, please give me a follow. Give me a hit that heart button. I really appreciate it. It means a lot. Same for you folks on YouTube. Thanks so much. Really appreciate it. Oh, wow. Luke Kyle, thanks for the follow. My name's AJ Steimenberg. I work on serverless stuff at Datadog, and I've been in the serverless space for a long time. So if you have serverless questions or you want to learn about AWS, I'm also an AWS hero. Happy to answer them. Send me a note, send me a message. I really appreciate y'all hanging out with me today. It's been a lot of fun. Let's go find someone to raid. Who do we got today? Oh, I know exactly where we're going. Let's go to we're going to go raid the Alt F4 stream. Yeah. Thank you so much, everybody. I had a huge amount of fun today. Thanks for hanging out. Go ahead, follow, subscribe on YouTube, and give me a follow on Twitter. Send me a DM if you have any questions about AWS, serverless, Datadog, any of those things. And join me tomorrow where we're going to deploy this onto Raspberry Pi and measure the latency end to end. Thanks so much, that guy Doru, and thanks everyone. Have a great rest of your day. See ya.